Thank you. Thank you for being here. Thank you, Radio Olmedo. Thank you, Valeria. Thank you, everyone, for organizing this meeting and for having us all together in this wonderful place. Today I want to have the opportunity of making a light review of some of the system responses to the severe hydric disturbance in Cuatrocienegas. This has been a long-term study. We are presenting with these people today, but there are many other students and colleagues that have been participating, but it's taken very long. I will just use 1 minute to make it very clear that I got here due to Valeria Sousa and Luis Iriarte, outspokenly defending this song when it was just started. So I know it's been said many times, but you know as well as I do that it would never be said enough. So thank you, Valeria, for a long time. Okay, we all know where we are. We are in this wonderful place. This is the butterfly. And over here, you can see the Turince system. There's a scheme here. We will go back to this. So I won't spend any time talking about the wonders of this place because I know that you know them. And that's what has us here today. Okay. Arid zones and semi-arid zones look terribly arid sometimes, but they always have a bit of water someplace. Even though if it's very scarce, an oasis can appear every now and then or more frequently. The desert springs, the wetlands, the pools in these type of zones are extremely important, and they are usually distributed in patchy ways. So they are also, they house lots of endemic species, and they contribute very importantly to species diversity, to ecosystem function. They are, and unfortunately, all these types of environments worldwide have been mismanaged and overexploited. They are all in a very risky situation, just like in Cuatrocienegas. You can see here how they create patches with a riparian vegetation all around, and here you can see the famous tomato leaves and some of the riparian species I will be speaking about during the following minutes. The ecological systems in Cuatrocienegas have been disturbed very badly for a very long time. When I got here, there were already several ponds that were gone forever, but you could still find many pozas, intermittent or permanent, and you could find the whole system more or less working. This is the Poza Turince, where the water spring is in the Turince system, and then you've got the creek, very proudly called river, but it was really a creek, a very important one. This is Rio Turince, this is the intermediate lagoon, and this is the last branch of the creek, and this is the final desiccation lake. Many of you know this place physically, but maybe some of you don't. And our work will be centered first here, and then here, and here. Okay? The Turince system was very important because of its size, its structure, its endemisms, its richness, and the ecosystem services that have not been quantified, but they are evidently or were evidently there. This is just an overview. This is how it looked in 2004 when I got here for the first time. And then by 2009, it dried out, and then this is the way it's been changing in 2017, 2023. And this picture, we took it last week. We were doing field work here last week, and you can see that the water is gone. It's not something to be taken lightly. It's very rich in gypsum, which is a characteristic of this zone also. You have gypsum patches that determine vegetation types. Oops, I'm sorry. Okay. The Chorizo River, the last branch of the Chorizo River, where the river mouth was, dried out in 2012, and you can see how it's changed from 2008 to 2025. In 2012, we got here, I think that the last drop of water dried the night before. There were fish corpses and steps on the mud, of birds and small mammals that had a feast the night before. It never came back. And again, this is how the riverbed looks now. This picture is from last week. Torres Orozco did first study on how plants were colonizing the dry riverbed, and she found these species, which are especially the first two, very characteristically riparian species. They were still colonizing and making use of the small amounts of water that were still available. The intermediate lagoon, which was extremely beautiful, looked like this in 2009 and looks like this last week. 2020 was a turning point because that's when the surface water disappeared, and then we got all these aquatic and semi-aquatic species, especially this, which is tufa. It roots on water, but the aerial parts are not under the water. And it was just, you can see, it was covering the whole thing. You couldn't walk here. It was very muddy, and you would go down, fall, and then you have to pull your feet out and then go back for your shoes. So you always stay there. And this is the way it looked in 2022, 2024, and last week. I'm going to be speaking about this lagoon in a while in a more detailed way. This is what the water spring. This is the way it looked in 2012. The disaster was already ongoing. The Chorizo lagoon was already dry, but still it was with clean water, clear, and it was a wonderful, wonderful little spot. Now the water looks like this. There is some water, apparently came back, and this is how it looks. This here is this part here. There used to be a small set of steps, of wooden steps, so you could go into the water, and now you have mud with hoofs of horses and donkeys, and actually there was a dead mule there. Yeah, it's this. The south bank of the Chorizo River was first described by Pinkara as a place with no apparent vegetation. Basically, there were very small stems and leaves, but really small, of the Stickless spicata, which is very, very frequent. And now then it was colonized by species that were more atrophilic, and then you have this very, that's how it looked last week. Okay. As a consequence of this dry out, when the spring lost its power, the river didn't get all the way to the lagoon, and then water found its way as it does usually does. So it started filtering underground at the sub-level. If you knelt and you stood up again, your knees would always be down. And a whole set of these formations appeared, locally called aras. These sinkholes have the same origin as the cenotes in the Yucatan Peninsula. This is the semi-karstic substrate, and they are dispersive soils. Numerous sinkholes were formed, really very, very abundant and very quickly. Sinkholes are common in this type of substrates, in karstic and semi-karstic substrates, but the speed at which they were formed has no precedent. And they represented what later we knew were ephemeral new habitats where the riparian species could hide from the disappearance of the habitat. You can see this is one of the big sinkholes, and some have water, and there are all sorts of stuff. Sinkholes are a direct response to the disturbance of the hydrological system. There's no discussion about it, and you will see how. In January 2008, when we started, there were already 121 sinkholes in the South Bank. Between 2008 and 2017, we made 51 census every 2 or 3 months, and we registered the open, newly formed, and closed sinkholes. Sinkholes can close, sand can accumulate. If there's water, then it will disperse again, and they will reopen. But if there's no water, they won't disperse, sand accumulates, and they stay closed. And the newly formed were also counted. And we consider these morphometric parameters. Again, you can see here, this is a big one. This is ARA 83. You can see the size. My colleague here. And what we find is that they formed a very patchy environment. It looked like an inverse archipelago. Instead of having empty pieces of land coming out of the water, we had pieces with water going in beyond. It was like a Gruyere cheese. It was very easy to fall down, actually. They provided shelter, shade, water, here's water. Even if they did not have liquid water, they were certainly rich in humidity and also in organic matter. And you can see they have all sorts of sizes and types of plants. The whole system of the sinkholes proved to be very dynamic. Here, in the blue line, what you have is the percentage of sinkholes with water. In 2010, there was a huge hurricane that damaged the community very badly, the Hurricane Renex, and then we had more water. And here, La Becerra was closed for a few months. And that closure was enough to recover water in the sinkholes. The sinkholes were still bad news. The sinkholes without water were even worse news. What you see in the red line is the number of sinkholes that we found in every location. So you can see that we got, we actually counted 254 sinkholes, but then the number of sinkholes started decreasing because they started to close. There was no water to disperse the soil particles. And this is the average, this is the percentage of sinkholes with vegetation. There was a very harsh winter this January, but basically, except for one exception, sinkholes will have vegetation establishing them. These are the most frequent colonizers. Samolus, Flaveria, and Sporinus are riparian hydrophilic species, and this is Sticlis picata, which is this stoloniferous Germini, and Sporobolus ailoides, which is sort of ruling the range right now. These are other colonizers. And I'm only showing you the frequency of how the species change. Here you have Sporobolus nigricans. You can see it tends to disappear. And here you have Samolus erectatus, which is already completely gone from the soil. Flaveria chlorifolia. And please pay attention here to the Sticlis picata and Sporobolus ailoides, which you can see here and here. And as you can see, they tend to increase. Sinkholes are very regular, and you can have lots of species, but they are disappearing. The trend analysis, just hold one step. The trend analysis showed us that September 2012 was really a turning point, a non-return point, because the surface, the depth, and the richness started decreasing and will never recover. And as for diversity, it took a bit longer. Sorry, as for the area, it took a bit longer in June 2024. This is one type of new habitats that were formed. But there's a new set of new habitats that's taking place right now. The colonization is taking place right now, which are the lagoon dry beds. This is the Turince lagoon, and this is the intermediate lagoon. We followed the Jeep World method, 2 squares inch lagoon, 30 per 30, with a set of 6 subplots, and 2 transects, and this is the work of a fantastic young woman called Xochitl, like that you read her in the file. And these are the species that we found in 2 years. This is the Churince lagoon, and the blue one is the intermediate, and this is the only shared species. We calculated abundance and frequency and cover, whatever, but we have no time to go for the details. If you want to see them, please join us afterwards. But the importance index value to show us very different behaviors in the Churince lagoon, which has been dry since 2009, and the intermediate lagoon, which start drying, well ended drying in 2020. You can see that basically we have this Tigris picata here in blue, which is this Anopheles vermilion, and Sporobolus xyloides, and 3 other species. Finally, in the Churince lagoon, we only have patches of vegetation, sparse patches, low cover, and only 5 species. The intermediate lagoon is different. There are many other species, but still these Tigris picata and Sporobolus xyloides sort of are present and have very important values. But another gramínea, Muehlenbergia robusta, which is in green, is also here. And then we have other species that are Hygrophilus, Gypsophilus, Holophilus. They play by ear, actually. Diversity is higher in the intermediate lagoon, but dominance is certainly more present in the Churince lagoon. The diacaric similarity index tells us that the 2 lagoons are different. And a dendrogram of three seasons. We didn't manage to finish the data we collected last week, but we'll let you know as well. So always separates the two lagoons as very different. And this looks very messy, but it's not. This is the set of subplots. The pink and red plots belong to the intermediate lagoon, and the green ones are the two 30 per 30 plots in Churince. And as you can see, the green spots tend to accumulate, they tend to move quite clearly with some seasonal trends. We still have to process the data. We just took to see if it's seasonal or it's really part of the successional process. Letters here correspond to species, and you can see, for example, F is for Flaveria, and that creates a group here. Flaveria is becoming less abundant all the time. So as you can see, even in the places where they mingle, because there are new species, the 2 lagoons are the process of colonization of the 2 lagoons is very, very different. In the intermediate lagoon, we have more richness and more diversity. The speed of colonization is definitely very different. It's faster, much faster in the intermediate lagoon. There are more hydrophilic species in the intermediate lagoon than in the Churince one, but soil homogeneity is higher in the Churince lagoon. We did make all the soil analysis, but we have no time to present it. We do have bulk density, which is higher in the Churince lagoon than in the intermediate. This is how TIFA looked in 2020, and this is how it looked in 2024, and they were very sparse individuals. So we do have a successional process, which is very interesting, based on these 3 parent species. This is the cross in the intermediate lagoon, and this is a seedling crossing the gypsum cross in the Churince lagoon. So although we are not sure yet, it seems that this arrested succession going so slow has to do with the presence of this crust. At the final last, this is a picture taken of the Chulite Lagoon from the Sierra de San Marcos, from our dear Spanish friend Irene Pisanty. We have learned a lot. Basically, we have learned that we don't know enough yet, and there are some, and the question is whether it's too late or not. But good old Jane Goodall will always say that there's hope in action. And this is the restoration of the wetland in Fosa Chiquero. Our friends from Conan kindly took us to visit it. And it's an ongoing process. It's still soon to call it a success, but it looks it will be a success story. So we do have the science. There are more questions than answers in science as usual, but I think we know enough how to do this. This was done with a very slow investment from private foundation, recovering water that was being lost through the pipes. They break, they leak, they are not perfect. Many people have helped us, and I thank them all, and I thank you for being here today with me. So is there any time for questions? Oh, sorry. It was a mess because I was told that I had 15 minutes, so, and then just a while ago I understood we had 25, so anyway. We'll be around here and we are willing to share information with you, and we'll have two posters. I hope we can talk over in there. Thank you very much.